The last video did a series of multiplying a monomial by a binomial. So now we're going to switch to multiplying a binomial times a binomial. So we're going to start with the example x plus 7 times x plus 4. So binomial means two terms. Hopefully we remember that. So x plus 7, that's two terms. X plus 4, that's two terms. But we're going to start by actually thinking of x plus 4 as one unit. So let me, and then distributing it across x plus 7. I'm drawing the lines here because that's where it's being described. So we're going to think of x plus 4 as like it's monomial, like the last video. And we're going to distribute it across x plus 7. So what that'll give is x plus 4 times x plus x plus 4 times 7. Hopefully we see what we're talking about there. All right, well, now what this is a monomial and a binomial. A monomial, binomial. So now we can do this other distribution. And if you don't like the x being over there, you can definitely write it as x times x plus 4, like in this order. I'm one of those people who it sort of bugs me to have the distribution on the right side. But it works. It's not wrong to distribute from the right. I usually just like switching the order to do it. So let's do it this way. So now I have x times x makes x squared. X times 4 makes 4x. Plus 7 times x makes 7x. 7 times 4 makes 28. And then finally we'd combine these like terms in the middle. So it's x squared plus 11x plus 28. So that's what I would consider the most complicated way to do this. It is mathematically correct, and it sort of connects to what we're just doing, where we take one thing and multiply it inside some parentheses. But now we're going to look at two other techniques, how to do this a little more smoothly. That's the idea. So example 3 says, imagine you are mapping out a rectangle. Sounds like I should probably draw a rectangle. Okay, lovely. Where one side is some unknown length x plus 7 feet. Okay, I'm gonna make it x plus 7 feet. And the other side is x plus 4. Then it says 4 component rectangles. So what it's talking about is oftentimes called the box method. And it may have been something that you've seen before in high school, or maybe not. But this is called the box method. And it's just a way to organize multiplications for distributing a binomial with another binomial. It actually works for trinomials. You could make this have like 9 boxes. So it expands well. That's one nice thing about this method. So what we're gonna do is multiply what's on the outside. So in this one, x times x makes x squared. This box 7 times x is 7x. This box 4 times x makes 4x. And finally, 4 times 7 makes 28. All right, if you may have noticed, those are the same 4 pieces that we got after we did this the long way in the previous problem. Almost always, not always, but most of the time, the diagonal is going to be like terms that we need to combine. So the x squared stays x squared. We're going to add these like terms to get 11x, and then the plus 28 is still there. So same answer, different way to organize what we're doing. So box method, I love it. If you love it too, this is something that you might want to use a whole lot. The other way to organize these multiplications is called FOIL. That stands for first out, outer, inner, last. And we're talking about what terms we're multiplying. because there are 4 different multiplications to do. So it's just a way to organize what multiplications we're doing. So here's any 2 binomials. I'm just using A, B, C, D, just so we can talk about what's going on. First terms mean A times C. Those are the first terms, because they're the beginning of each of the parentheses. Outside is A and D, because if we're viewing this as like inside, outside, A times D is the outside. Then the inside terms are the B and the C, so that's the I. And then finally, the last terms are B and D. So that's why this is called FOIL. Oftentimes you'll just see people do the lines and say, oh yeah, that's FOIL. So if this is something you know, awesome, we're gonna try it this way. Some people though might decide the box method just works better for them, and that's totally fine. And other people hate the box method and wanna use FOIL all the time. Great. They work equally well to organize what we're multiplying. That's all we're doing. So we're gonna do that same example that we've done a couple ways, this time with FOIL. So I'm gonna do x times x times 4, right? That's the first outside. And then we'll do 7 times x, 7 times 4. That's what those lines are doing. So x times x is x squared. X times 4 is plus 4x. 7 times x plus 7x. And then 7 times 4 makes 28. Just like all the methods, the next step is we have to combine the like terms in the middle. So final answer is still x squared plus 11x plus 28. So for a lot of people, this is a faster method, but if you're getting mixed up, use the box is how I would decide. But either one works perfectly well. Let's try another couple with this FOIL method. So I'm going to multiply the 2x times the other parentheses. So 2x times 3x makes 6x squared. 2x times negative 7 makes minus 14x. Are we seeing hopefully where those 2 came from? We're multiplying. Then we do the inside and the last. So we're multiplying y times the other parentheses. Y times 3x is plus 3xy. We just sort of put them together if we're multiplying things that aren't similar. And then finally minus 7y. So a negative 7 times y makes minus 7y. This one's different because there aren't any like terms, right? We can't add an x with an xy or a y with an xy. Definitely not with an x squared. So this is just done. That's the final answer. All right, let's try one with fractions because we want to keep practicing with fractions so that we don't feel overwhelmed when we see them. But the steps are the same. I'm multiplying the first, outside, inside, last. Now, some of you may have learned FOIL in ALEKS, maybe last term. They actually write FOIL. I don't really want to do that, but I'm basically going to be writing, yeah, maybe I will. So the first, because I do need to write this out a lot more than I was up here because I can't do 1/2 and 3 times 2/3 in my head like I could 2 times 3. So I got to write it out, so I may as well do it sort of the ALEKS way. Let me put the x's in there though. All right, so first is 1/2 x times 2/3 x. Does anything cancel? When dealing with fractions, especially with multiplication, we want to see, can I cancel anything? Oh yeah, the 2's just cancel. So I get 1/3, and then x times x makes x squared. That's not so bad, hopefully. Okay, let's do the outside. That would be 1/2 x times negative 4/3. If you have a fraction that's negative, put the negative with the top number, always. Now, if you don't like the whole canceling before, you could also multiply first, but then you would need to reduce your fraction. So like if I multiplied this first and got negative 4 over 6x, that's not reduced. We got to do the divide by 2, divide by 2. And that's what you could have reduced before multiplication too, right? Either multiply first, then reduce, or reduce first, then multiply. All right, this one I get negative 2/3 x. All right, so that's the outside. Inside, I'm multiplying those two. So that would be 3/4 times 2/3 x. Does anything cancel? Yeah, I'm not messing with these threes. Multiplying by 3, dividing by 3, those go away. And you could reduce the 2 over 4 at this point, or write it out and then think, oh yeah, I need to divide by 2, divide by 2. So that'd be 1/2 x. All right, last two terms. 3/4 times negative 4/3. What cancels? Well, the 3's cancel and the 4's cancel, but there is a negative left behind. When everything cancels, that's 1. So in this case, it'd be negative 1. Or if that's confusing, I know for some people, fractions can be a little overwhelming. If we think of it as negative 12 divided by 12, you just multiply, well, that's also negative 1, right? If you divide it by 12 on top and bottom, you'd get negative 1 as well. I'm not going to write that out necessarily, but I wanted to make that clear that like if the canceling before you multiply isn't for you, just make sure you know how to reduce at the end. Phew. All right, are we done? Unfortunately, we got some like terms. Both of these have x's. So I need to take negative 2/3 x plus 1/2 x. And to add negative 2/3 and 1/2, we need a common denominator. We need to make them both 6. So the first fraction, to make the denominator 6, I need to multiply by 2. So this would be negative 4 over 6x. 1/2 out of 6 would be 3 over 6, because 3 out of 6 is the same as a half. Or think of it as multiplying by 3 to make the 2 into 6. So we got to multiply 1 times 3 on the top. And that gives us negative 1/6 x. All right, so now we got the middle term. So final answer, when we put it all together, is 1/3 x cubed minus 1/6 x, and then minus 1.